1, 1. So cross them, so -2 plus 2 is gonna be 0. -2, and then -2, so +2. And then 5 plus 8, but then the j term is the opposite of what you get when you do that. And then 5, again, plus 8. Okay, so 0, -13, 13 is the cross of those two vectors. So if we graph that, 0, -13, 13. Again, it's showing exactly what I want to show. I think I'll close these a bit. And I might dim the lights a little bit more so that you can see what kind of went on. I'll turn them on. Alright, I'll turn it back on in a second, but the two yellow vectors are the normal vectors to the plane. We cross them and it created that pink vector. The pink vector I know is not lying on the line we actually want, but can you guys see it's parallel to it? Like here's the line of intersection, and the pink vector is parallel to that line. So if I just set a point that I know is on my line, and I use this as its direction, then I will get the line of intersection. So the cross of these two normal vectors gives me the direction of the line of intersection, because that direction has to be parallel to both planes, since the cross product is perpendicular to the two normal vectors. So again, it didn't give me the line itself, because you're drawing it from the origin, but it's parallel to the direction of the line. So now we just have to find a point we know is on the line, and then we can use that as the direction. Okay, so this gives us the direction of the line of intersection. Alright, so now we need to find a point that we know is on the line, and if the point's on the line, it has to be on both planes. So basically you're solving a little system of equations to find a point that lies on both of the planes. There's not really a standard, this is what you always do to do this. It's kind of like a little algebra crapshoot of, you know, plug things in until you reason out a point that's on both lines. The book, if you're following the book, they usually use a lot of zeros because they make things clean. So for example, if I made x 0, then I would get -2y minus 2z equal 1, and I would get y plus z equals 6. So assuming my point has x equals 0, I get these two equations, and you can solve these two equations however you would like. I think I will multiply this one by 2, and so I will get 2y plus 2z equals 12. Hang on, that's gonna, oh no, sorry. That's weird. It looks like I'm gonna get a non-point, but we know the two planes intersect. So I guess they just don't intersect at a place where x is 0. That must be what's going on. Because if I add these, I'm going to get 0 equals 13, which we know is not true. So x equaling 0 must not give us a point that is, we know is on both of them. So why don't we try making z 0? So 5x minus 2y, 4x plus 1y. So if z is 0, then my z's cancel out. And kind of same thing, you can solve this any way you want. With this y, 1y, I might actually do a substitution. So then I might substitute that into the first one. Okay, so I took this equation, just rewrote it, solved for y, and then used that up here. So 5x minus 12 plus 8x equals 1. So 13x equals 13, so x equals 1. So my point so far, x is 1, z is 0, and y would be 6 minus 4, or 2. So let's just double check that that's actually on both planes. 5 minus 4 is 1. 4 plus 2 is 6. So yes, this point is on both planes. But as you can see, there's infinitely many points you might come up with. I came up with that one by just making z 0, but you know, if we made z1, you're going to get a different point. So just realize, again, this is another situation where your answer could look different than the book and still be right. So you have to kind of, you know, stay on your toes about checking. So if we work with parametric, then I'm starting at that point that I know is on both. X was 1. My direction is 0. So 0 times t is just going to give me 1 for the x. So x stays 1 on this line, which seems a little, it doesn't exactly look like that on the picture, but I guess once we graph it, we might see that. And then my y is 2, and the direction is negative 13, and then 0 and positive 13. Okay, so this is my parametric, but then to get symmetric, we have x equals 1. That's just got to be part of our information. And then we have y equals 2 minus 13t, which means y minus 2 divided by negative 13 equals t. And we have z equals 13t, which means z over 13 equals t. So x equals 1, and y minus 2 over negative 13 equals z over 13 is the other piece of information, okay? So we have to list both of those pieces of information. And again, you could clean this up. If you didn't want the negative in the denominator, you could rewrite it as 2 minus y. Make 2 minus y over positive 13. You could also